This video will go over the three congruence axioms for line segments. So the underlying assumption that we have coming into these three axioms is that we're already in a geometry, specifically an incidence geometry, so all three of the incidence axioms are holding, as well as all four of the betweenness axioms are also satisfied in this geometry. This means that naturally we have all the consequences of the incidence and betweenness axioms, so line separation, plane separation, crossbar theorem, and our unnamed proposition 6.1. Now, with that said, these congruence axioms dealing with line segments are specifically looking at what do you need to have happen so that when you define line segment congruence inside of your model, so looking at when two line segments are congruent to each other, how do you know that that definition really is giving you what you want or what you would expect line segment congruence to act like in your geometry? So let's look at the first one. In terms of the first axiom with line segment congruence, uncreatively called C1, C for congruence. So suppose here you've got some line segment and you've got some ray in your geometry. So it doesn't matter what line segment you pick, it doesn't matter what line or really a ray that you also pick. And we went ahead and called the starting point of the ray point C, just because the ray has a starting point. So according to this axiom, what you then get is that there's always going to exist some unique point D on your line, or really on your ray, where the line segment AB is congruent to your line segment CD. Note what this congruence axiom is really talking about. This congruence axiom tells you that you're able to copy any line segment onto some other line elsewhere in the geometry. Okay. So, second congruence axiom, uncreatively called C2, says suppose you have a line segment AB and you already know it's congruent to line segment CD, and suppose you also know it's congruent to some other line segment EF. Then this congruence axiom tells us that, well, if AB was really congruent to these other two guys, CD and EF, well, of course, all three of these line segments are really congruent to each other. Note, this first part right here is exactly the same as common notion number 1 back in Euclid's Elements. And then we also have the tag on, or the second sentence here, that every line segment is always congruent to itself. And notice that guy is totally common notion number 4 back in Euclid's Elements as well. So this C2, this second congruence axiom for line segments, deals with all of the logic, or if you will, the algebra that's associated with your line segments. Now the third congruence axiom, this one is phrased a little bit different because notice it actually, you have to have betweenness defined in your model in order for the third congruence axiom to even have a potential of existing, because we have the point B is between A and C. So suppose you've got these 3 points A, B, and C, where B is between A and C. Notice what that tells us back from our betweenness axiom. That means we do know that these 3 points are all different points and they're all on the same line. Now, suppose we have a second grouping of 3 points, D, E, and F, where point E is between D and F. Notice again, all three of these points, D, E, and F, have to be on the same line. They're all different points. So we get these two situations. Now, it is possible that A, B, C, and D, E, F are all on the same line, but I did the more common case over in the picture. Then the conclusion says, well, suppose line segment AB is congruent to line segment DE. In the picture there, the green highlighted line segments. And suppose we also know that B, C, and EF are congruent to each other. Now the orange highlighted line segments. Then the conclusion here is that if you look at the line segment AC, it has to be congruent to who? Well, it has to be congruent to the new entire guy of DF. Okay? Note this last congruence theorem totally is the setup for how we're going to be adding line segments together. We'll actually have a specific proposition that deals with adding line segments, but really this third axiom is going to give us all the information that we need in order to get to adding line segments. The first one allowed us to copy line segments to other places in the geometry, and the middle one really was some logic dealing with when two line segments are congruent to each other. So I'm going to put in quotes there how sort of equals, if you will, is defined or used with respect to line segments.